Hi everyone, this is Dr. J. Ravindranath Reddy, working as Assistant Professor in MLR Institute of Technology, Hyderabad. So we are discussing the concept Numerical Methods and Integral Transforms course. In that course, we are discussing the concept of interpolation. In this interpolation, we are taking Gauss forward and Gauss backward interpolation. So in this video, we will see what is Gauss forward interpolation, when we have to apply this Gauss forward interpolation, and what is Gauss backward interpolation, when we have to go for this Gauss backward interpolation, and we will take some problems on both Gauss forward and Gauss backward interpolation. So first we will take this Gauss forward interpolation. So this Gauss forward and Gauss backward interpolations are totally depends upon the central difference table. In the previous video, we have seen how to construct the central difference table here. Now, let us take the formula of Gauss forward interpolation. So, this is our Gauss forward interpolation. So, that is given by y naught plus p into delta y naught plus p into p minus 1 by 2 factorial into delta square y suffix minus 1. And like this, we have the formula. And we have infinite number of terms here. So, we no need to consider total terms here. So, it depends upon the central difference table here. The number of terms we have to consider in the formula. Suppose in the central difference table, our last column in that central difference table is ending with a delta power 4. Then we have to consider up to this term. Suppose if it is ending up to delta cube term, that column, then we have to consider only up to this part. So, number of terms in the Newton Gauss forward interpolation is depends upon the difference table what we construct here. So this is the formula. P is equal to x minus x naught by h. So all y naught value delta y naught delta square y suffix minus 1 delta cube y suffix minus 1 delta power 4 y suffix minus 1. All these values you will get from the central difference table. And this is the formula you will use to find out the p value here. So that is x minus x naught by h. So here we can also represent this Gauss forward interpolation with another notation, another operator. That operator is represented with a small delta. So this small delta is also we can call it as a central difference operator. But up to now we have taken only the help of forward operator, that is delta. So we can also represent this same Gauss forward interpolation or Gauss backward interpolation with a small delta. This small delta we can call it as a central difference operator here. So wherever we are having delta y naught, we can take that delta y naught with so we can take that delta y naught with small delta y suffix 1 by 2 delta square y suffix minus 1 we can represent with this value here. So in this formula, wherever we are having delta y naught, we can represent with delta y naught with a small delta y suffix 1 by 2 and delta square y suffix minus 1 we can represent with a small delta square y naught. So like this. So we can also rewrite this Gauss forward interpolation in terms of central difference operator, that is in terms of small delta here. So this is after replacing that, this is our Gauss forward interpolation formula in small delta, that is in the central difference operator form. So basically we will use this formula since you are very familiar with the forward operator and how to construct this forward operator, how to represent that forward values of y with a forward difference operator. So in general, these values are represented with these standard formulas. Suppose if you want to go for this delta square, small delta square y suffix minus 1, small delta square y suffix minus 2 or small delta square y suffix 2. All these values are represented with these standard formulas. Gauss backward interpolation formula. So this is our Gauss backward interpolation formula, that is y is equal to y naught p into delta y suffix minus 1. So these values also you will get using this central difference table, and we have the same formula to find out the p values also, that is x minus x naught by h. So now whenever we want to apply this Gauss forward and Gauss backward interpolation, so whenever we want to apply this Gauss forward interpolation, whatever the value we get for p, that p value must always be a positive value. So here p value must be positive value. According to that, we have to consider our x naught value whenever we want to apply this Gauss forward interpolation. This is very important. Once again, I will repeat this. So if you want to apply this Gauss forward interpolation, whatever the value we get for p, that p value should be always positive. So it lies between 0 to 1. So like this, in order to satisfy that p condition, we have to assume our x naught value from the table. That is the important point we have to remember. Similarly, in the Gauss backward interpolation also, whenever we want to apply this Gauss backward interpolation formula, this p value should be a negative value here. That is, always the p value lies between minus 1 to 0. In between minus 1 to 0. So in order to satisfy this condition for p, we have to consider our x naught value here. So whenever we want to apply this Gauss backward interpolation, whatever the x naught value we consider, that x naught value always should be greater than our x value given in the problem. Suppose if the x value is 38, now if you want to apply this Gauss backward interpolation, we have to consider our x naught value as 40 if it is in the table, or this 38, whatever the x naught value we consider, that should be greater than this 38. That is the important point we have to remember. Now let us take one example on the Gauss forward interpolation. How to construct this, how to derive the formula, what are the terms involved in that formula of Gauss forward interpolation. So this is our value we have to find out, y of 25. So y of 25, this is the value. This is, once if you observe this one, this is in the form of y of x. From this you compare that x value here. So our x value is 25. So x value here in the problem he has given as 25. And the data he has given as y suffix 20 is equal to 24, y suffix 24 is equal to 32, y suffix 28 is equal to 35, y suffix 32 is equal to 0. So whatever the values we are having on RHS, you consider these values as y values, and whatever the values we get in the LHS side, you consider these values for x variable. Okay. Now this is the table here. So whatever the data he has given, I have constructed the data into the tabular form. So this 20, 24, 28 and 32, these are the values of x. So I have taken in this column 20, 24, 28, 32. On the RHS side we are having 24, the first condition. So I have taken that value as first y value, and the next one is 32, second y value. This is 35, third y value, and this is this is 40. So take this value as 40. Okay. So now this is the data. Now first we will construct central difference table here. So this is the formula we have seen. So now we have to identify this x naught value here. So our problem is finding the value of y of 25. So here you will get x is equal to 25. And here, since we are applying the Gauss forward interpolation, our p value should be a positive value here. So what is our formula here? P is equal to x minus x naught by h. So we know this x value, that is 25, minus h is nothing but the common difference between the values of x. So 20, 24, difference is 4. 24 and 28, the difference is 4. So we have a common difference. So now, in order to get this p value as a positive value, whatever the value we consider for x naught, that should be less than 25. That is, nearest to this 25 is 24, which satisfies our condition. So we consider our x naught is equal to 25. Now represent this 24 as x naught value. Above this value you represent with x suffix minus 1, and below this 24 you represent this x1, x2. This is very important here. So identifying the x naught value, it depends upon the formula what you are using here. Gauss forward, since it is a Gauss forward, according to our condition, our Gauss forward value, p in the Gauss forward, the p value should be a positive. In order to get that p value as a positive value, whatever the value we consider for x naught, it should be less than x value here. Our x value is 25, so we have to consider x naught value less than 25. So less than 25 is 24. We have to consider only the nearest value. Should not go so 20 is also less than 25. Now why should we consider for this x naught is equal to 20, means we should not consider x naught equal to 20, because we are having nearest value of this 25. Nearest less than 25, nearest value is 24, so we have to consider this 24 as x naught value here. And this, you consider this corresponding y values as y naught, and this is y suffix minus 1, and this is y1, and this is y2, and find out the differences here. So 32 minus 24, you will get 8. So we will represent this with delta y suffix minus 1, and this 35 minus 32, that is 3, you represent this value with delta y naught. And next one is 40 minus 35, that is 5, you represent with delta y suffix 1. And similarly, go for the next column, find out the differences here. 3 minus 8, 3 minus 8, you will get minus 5, that is represented with delta square y suffix minus 1. So 5 minus 3, that is 2, which is represented with delta square y naught. And find out the differences here. You will get 7, which is represented with delta cube y suffix minus 1. So our central difference table is ending with delta cube. So while you are taking this forward interpolation formula, we have to consider the terms up to delta cube only. No need to go for the delta power 4, delta power 5 here, because we have stopped our table at delta cube, third forward differences of y. So we have to consider this up to this delta cube only. Okay, now here we got, now calculate this p value. 25 minus 4, that is 1 by 4. You will get this value is equal to 0.25. That is the thing what we have taken in the previous. That's why we have represented with x naught and these y values here. This is y suffix minus 1, the same thing. And this is delta y suffix minus 1, delta y naught, delta y1, delta square y suffix minus 1, delta square y naught, and this is our delta cube y suffix minus 1. Now let us see how to derive the formula by using this central difference table. So first here, whenever you are using this Gauss forward interpolation, first we have to take our y naught. So this is our y naught term here. So our x value is 25, that is which lies between 24 to 28. Whenever our x value is greater than this 25, our 25 is after 24. So here, in order to come from 24 to 25, we have to move downward direction here. So now we are at this point. Now first, if you want to go for the next column, from y naught you move towards downward direction. Why we are moving towards downward direction? Because our 25, this is our 25. So 25 exists below this 24. So below means downward direction here. So in the next term, we have to take which contains delta y naught. So P into delta y naught. So now we are at this point. Now if you want to go for the next column here, first we have moved towards downward direction. Now from this column, you move towards upward direction here. So our upward direction, it is represented with delta square y suffix minus 1. So our second term contains delta square y suffix minus 1. Now we are at this point. Now upward direction is completed. Now move towards downward direction here. So one we have to move downward direction. Next step we have to move upward direction. Like this, alternatively we have to move upward, downward until we get the last value. So here, so our last value is represented with delta cube y suffix minus 1. So we have taken that delta cube y suffix minus 1. And one more, this is about this, the coefficients of this delta y naught, delta square y suffix minus 1, delta cube y suffix minus 1. Now once here, if you concentrate on P here, so since we are applying the Gauss forward, we are very familiar with the Newton's forward. While you are taking the Newton's forward interpolation formula, first we are taken P in the next column, in the next term we have taken P into P minus 1. In the Newton's forward also we have followed the same procedure. Now here, whenever we come to the next term, so we have subtracted 1 from P. So now immediately in the next term, you go for the addition here. So once if you have completed the addition and subtraction of 1, then we have to go for the next number, that is 2. Then first apply subtraction, and like this we can easily remember this Gauss forward and Gauss backward interpolation formulas here. So now we got the P values, you substitute that P values here, and delta y naught, we got that delta y naught is equal to 3, substitute that delta square y suffix minus 1, we got minus 1, and substitute wherever we are having P, replace that P with 0.25, and finally you will get our, this is y of 25. So finally we got y of 25 equal to 32.945. So this is the way how we can apply Gauss forward interpolation. I think with this example you have understood how we have to consider that x naught value in order to get that P value as a positive value here, and how to represent these coefficients of this delta square y of these terms from the central difference table here. So this is example for Gauss forward interpolation. Now we will take the example of Gauss backward interpolation formula. So how to choose this x naught value in order to get that P value as a negative value here. So use Gauss backward interpolation to find out f of 32. So whenever we are having f of 32, we have to represent this in the general form, that is in the form of f of x. From this we have to get our x value here. So x is equal to 32, and this is the data he has given like in the previous problem. So construct this in the tabular form. So our x value is 25, 30, 35 and 40. So represent that x values in the x column, and its corresponding RHS values we are having, you represent that as y values here. Now given that our x value is equal to 32, now we have to consider our x naught value in the table. So first we will go to this central difference. So our x value is equal to, x is equal to 32. So you take x is equal to 32. Now this is our formula of to find out our P value. So x minus x naught by h. So now in order to get this P value as a negative value, this x naught value should be greater than this x value. Our x value is 32. Now we have to go to the table and identify the nearest value for 32. Once if you observe that nearest value for 32 is 30, then compared to this 35. So if you substitute this x naught is equal to 30 here, you will get a positive value of P. But since you are applying the Gauss backward interpolation, where that P value should be a negative value here. So when we consider x naught equal to 30, then our condition will not accept. So instead of considering this 30, we have to go for this 35 here. So if you substitute x naught is equal to 35, then definitely you will get a negative value, and the common difference is 5. So you will get minus 3 by 5. Since here you are having a negative sign, so this is p value is, you will get a negative value here. So like this, we have to choose our x naught value from the given data. So now we got the clarity how to get that x naught value based on the formula which you are applying. So since you are applying the Gauss backward interpolation formula, according to that Gauss backward interpolation formula, our p value should be a negative value. In order to get that p value should be a negative, whatever the value we consider for x naught, that should be greater than our x value. Our x value is 32. 32 greater than means we have to go for the next number, that is 35. So this is our x naught value here, and consider its corresponding y value as y naught, and remaining values with y suffix minus 1, y suffix minus 2 and y1. And now as usual, we have seen how to construct this central difference table. Follow the same procedure what we have discussed in this previous slide and in the previous video also. Follow this. We got these values. So this is our central difference table here. Now we are using this formula. So now we are at this point y naught. So the first term is y naught. So our x value is 32. So it lies between 30 to 35. That means if we are at this 35 value. Now if you want to move towards 32, we have to move towards upward direction here. So 32, from 35 to 32 we have to move upward direction in this table. So from this y naught, move towards upward direction. So now consider this move towards upward direction from y naught in the next column. So this is our delta y suffix minus 1. So here that's why we have taken this delta y suffix minus 1. Now one time we have completed upward direction. Now from this column, move towards downward direction. Our next term is delta square y suffix minus 1. So that's why we have taken this delta square y suffix minus 1. And the next one, so downward direction is completed. Now move towards upward direction. This is delta cube y suffix minus 2. So that's why I have taken delta cube y suffix minus 2. Now since you are applying the Gauss backward interpolation, so we are very familiar with the Newton's backward interpolation. So according to that, you take this y naught. So instead of taking y naught, you concentrate on the p. So after p, we have taken p into p plus 1 in the Newton's backward. Follow the same procedure, only you concentrate on the p terms. And here in the next, adding 1 is completed. Now immediately go for the subtraction. So p into p plus 1 into p minus 1. That is our p term here. By number of terms you are having, the numerator is 3. So you take 3 factorial, and this is fixed delta cube y suffix minus 2. Okay, now you substitute all these values, p values on this in this standard formula. You will get our y value. Y is nothing but the value of y at x is equal to 32. So when x is equal to 32, we got our y value is equal to 0.3165. Okay, so this is the way how we can apply this Gauss backward interpolation formula, and from this central difference table, we have seen how to construct this Gauss backward interpolation formula. So in this video, we have seen Gauss forward and Gauss backward interpolation formulas, and how to apply this Gauss forward. When we apply this Gauss forward and Gauss backward interpolation formulas, we have seen some examples here. So this Gauss forward and Gauss backward interpolations and whatever the interpolation formulas we have discussed in the previous videos, that is Newton's forward and Newton's backward, all these are applicable only whenever that difference between the values of x is common. So we have some more interpolation formulas are there. Suppose whenever the difference between the values of x is unequal. Suppose if we take x is equal to 1, 3, 4, 7. So the difference between this 1 and 3 is 2, and the difference between 3 and 4 is 1. So we are having unequal difference here. So whenever the x values are unequally spaced, then how to find out the values of y for this situation, for this case? So this we will discuss in this, that is Lagrange's interpolation formula. So this Lagrange's interpolation formula is used to find out the value of y at a given particular value of x whenever the x values are unequally spaced, or whenever the x values are having unequal difference between the values of x. This concept we will discuss in the next video. Thank you.